Haha, edit. So now I've edited it. I'll just start the video here. Let me begin with a word of prayer before I forget. Dear Father, we thank you for this day. Again, I thank you for this class, this opportunity we have just to meet and study your creation. I just pray that we glorify you what we do this day and just to guide our steps, Lord. In your name I pray, Lord Jesus. Amen. All right, let me dive right into it. Let me do a problem. Like I talked about a problem at the end of class last time, but it was kind of hurried, right? So, example 1. Suppose you've got, I don't know, this right here. Maybe this is actually y equals to, I don't know, 3x plus 2. So if that's the case, obviously my graph is not got the same scaling. It doesn't have the same scaling on the x and the y axis, right? So like if you use different scaling on the y and the x, then what you might think of as being slope 1 wouldn't actually be slope 1, right? Only when x and y have the same scale is like a 45-degree angle a slope 1 thing. But anyway, enough about that. So here's an equation, right? Here's a line. You guys tell me what this point is. What? Y-intercept, right? That's 0, 2, right? Okay, great. So here's the question. Find the distance from line to, let's say, I don't know, 4, 3. All right, so 4, 3, I don't know, it's like, you know, over here somewhere-ish. All right? How do we find the distance? What should that be? Yep.
I was going to say, wasn't this the one where we do the calculate the perpendicular line, see where the point of intersection would be?
Right, yeah, exactly that. So we want to find the perpendicular line, right, like this maybe. And the point where that intersects will give us the point on the line which is closest, right? So this right here is the distance that we want to figure out, the distance d. So how do we find that point? How do we find that point of intersection? Do you guys know? What should we do? So baby steps, right? First of all, what's the equation of the perpendicular line? Let me put it in words. Yeah, this is a line with slope m equals to, you guys fill in the blank, which goes through, I'll do that part. Where does it go through? It goes through the point 4, 3, right, by construction. So the real question is, what's its slope? Can you guys tell me? -3 is almost right. -1 over 3, right, -1/3. So the slopes must be negative reciprocal for perpendicular lines, so -1/3. Now we have a slope, we have a point, so we can write down its equation. The equation of the perpendicular line is y is equal to 3 minus 1/3 times x minus 4. So this is the equation of the perpendicular line. Let me do it this way. Perpendicular line, all right? I've got an equation of the perpendicular line. How do I find the point of intersection now? Let me give it a name. Bob. How do you find Bob? Where does Bob live? The intersection, what's that mean? All right, Michael, watch out. Hey, good catch. I've got an assist. You can throw it out. The trash cans there. Thank you. That may be my first assist. Let's see here. That wouldn't be an assist for me. That would be an assist for you, right? I don't know. You people who follow these things, like basketball, right? Is that basketball? Okay, that's where they put the sphere into the ring, right? Sorry. Anyway, I digress. So where Bob lives is that both lines are true, right? So we have 3x plus 2 is equal to 3 minus 1/3 of x minus 4. This for Bob. All right, for Bob. Then how do you solve that equation? Fractions. Let's multiply by 3. Multiplying by 3, I get 9x plus 6 is equal to 9 minus, parentheses are your friend, x minus 4. All right, let's move all the x's to one side. So I'm going to have 10x over here equals to what? 9 plus 4 minus 6, also known as, let's see here, 7? Feels like a 7. All right, 7, great. So thus x is equal to 7 over 10. For Bob, x is equal to 7 over 10. Now that doesn't yet tell me where Bob is, right? So where's Bob? X equals to 7 over 10. Y is equal to 3x plus 2, right? Which is actually 3 times 7 over 10 plus 2. Why am I doing that? Because Bob is on the line 3x plus 2. Why don't I use the other equation? Because the other equation's got a fraction in it, and it gives me no joy to use it. 3x plus 2 is the nicer formula. Use that one, right? Now then, what do you get? 21 over 10 plus 2, also known as 41 over 10, I suppose. So what is Bob? So Bob's actually the point 7 over 10, comma 41 over 10. Was that me dinging or was that you guys dinging? That was you guys dinging, right? Somebody dinged. Or is that because I've got this plugged in? There you go. Okay, this is all lovely. We found where Bob lives, right? But how far is Bob from the point 43? How do we figure that out? How do you figure out the distance? What is the distance from the point 7/10, comma 41/10? And if you'd rather use decimals there, you're welcome to the point off the line, which was given, what was it, 4/3, right? Well, there we use the distance formula, right? The distance is equal to the square root of what? Let's put this. Why am I doing these fractions? This is dumb. What was this? Come on, guys. This is what? 0.7, 4.1, right? You feel better with me writing that? Right? 2 less fractions in the world. It's a good thing. So 4 minus 0.7 squared plus 3 minus 4.1 squared. This is the distance formula. The difference is in the x, then you square it, plus the differences in the y squared. Add them together, square root of all that. This is the distance formula, right? Now, so what's that work out to? Oh goodness, I don't know. I need a calculator for that, right? Which I have left in my office, so I'm at your mercy. Oh, let's see here. Texas Instruments, as far as the eye can see. You're gonna make me work. All right, thank you though. Beggars can't be choosers. Minus 0.7. Square that thing. Where's the square button? Give me my square button.
Second, and then
Oh, second. Second. Oh no, it's there. I see it. Squared. All right. Plus That's 0.9. So 0.9 squared. Yep. Square root. I'll find it eventually, guys. I get 3.42. Did you guys get that? Anybody? How many people got 3.47? Show of hands. How many people didn't calculate it? Show of hands. All right. So ignore those people. How many people calculated got 3.47? Anybody calculated and get something else? I mean, it was me, but I don't want to take... All right. So there's an important life lesson here. How do we judge mathematical truth?
Proofs.
No. Consensus. So the consensus is 3.47. So that must be the answer. Okay, this is not actually a real life lesson, but when I'm working with a calculator I'm not familiar with, I will trust you guys. Anyway, any questions about this problem? This is by far the hardest line problem, right? Because it involves so many different ideas all at once. You have to put them all together. Yeah.
Can you go through like step by step of the purple ones, like what each one represents? So like I see 3x plus 2. That's the slope of the original one. Then the next one, the 1/3 is we get from the slope of the opposite line.
Right.
And we calculate all that out.
So the reason we're looking at this is that point is on both lines. So we set the y for the one line equal to y to the other to find the point which is common to both. This is just solving for x. And then once we find that, we plug it into the equation. We just chose one of them at random. Well, not really, the one that was easier. Plug it in, that gives us the y value for the point of intersection. That's the point of intersection. Then we need to find the distance between these points. So we take the squares of the difference between the x and the y atom. Yep. Yes, sir?
So pretty much what you did here is you made the perpendicular line.
Mm-hmm.
And then you put together the perpendicular line and the original one, and then you solved for x there, right?
Right.
And then from there you solved for y.
Yep.
And then once you got all that, you used the distance formula to calculate the distance.
That is true. Yep. So, thank you guys. I'm just making sure I got it all on camera. All right, now that we've done that, we must move on. So, again, I think this is pretty much the hardest lines problem that there is, right? You know. It's a still somewhat difficult problem in Calculus 3 when I ask it. Like in Calculus 3, I'm asking almost the same question, but instead of having a line and a point off the line, they have a plane and a point off the plane, and then they're asked what's the distance from the point to the plane. But you know what? The same idea is the way you solve it. You find the thing which is perpendicular to the plane, and the length along that perpendicular is the distance to the plane. So it's like, I don't know. It's kind of funny, because you guys are, of course, in very different courses, but there's kind of a similar kind of problem you're working on. All right, anyway. Speaking of planes, that's what we're about to get into. So we want to talk about how to solve 3 equations and 3 unknowns. All right? So 3 equations. So solving linear systems is what we're up to here. I'm going to illustrate by example, because if I tried to illustrate by general theory, that would be dumb. Here, that would be dumb. Example 2. So suppose you're up against x plus y plus z equals to 0, and you've got x minus y plus z equals to 1, and you've got, I don't know, x plus 2y minus z equals to 3. All right? So this would be 3 equations and 3 unknowns. All right? So you have some homework problems on this, and I should show you how to do these kind of problems, right? Now there's basically two ways to solve these. What are the two ways? The two ways are substitution and elimination. All right, I will describe a general substitution method for you, and we'll solve a harder problem with that, okay? But this one is easier, and it really is better to use elimination for this one. And let me suggest that we use notation. Like, let's call this equation 1, let's call this equation 2, let's call this equation 3, just to give a name to them, right? All right, so what I would suggest is we take 1, we take 2, and we add them. So, you know, x plus y plus z equals to 0, x minus y plus z. Oh, wait a minute. Should I add these? What do you guys think? Add or subtract? Does it matter? So add's okay. The y's cancel. But what happens when I subtract? Oh, yeah. The x's and the z's both cancel, right? So that's really nice. When I subtract these equations, I just get 2y is equal to 0. Well, that was nice. We just found out y is equal to 0. Yep.
Isn't the second equation equal
Ah! So that makes this a minus 1, which makes, no, a fraction, and a negative fraction at that. The horror. Okay. Is good? All right, 1 down, 2 to go, because we still need to find x and z. What else is really nice here? How about what if we were to say add equations 2 and 3? What would happen there if we did that? 2 and 3, let's add them. So I've got x minus y plus z equals to 1. See, I learned. X plus 2y minus z equal to 3. And I think it would be ever so nice if we were to add those. What happens when we add them? We get, 2x. And what's minus y plus 2y is y. The z's cancel, that's wonderful, equals to 4. Now, question? No? Okay. What should I do? I should substitute. I know y is equal to minus a half. So I should put that up in here, right? So I've got 2x minus 1/2 equals to 4, right? Now what? Now we can solve for x, right? So let's see here. 2x is equal to 4 plus 1/2. 4 plus 1/2 is, well, it's 9/2. And then we divide by 2. We get x is equal to 9 divided by 2 times 2, which is 4. So apparently, another fraction. Hideous. 9/4. All right? Great. Now what? Yeah, pick one and plug both in. I think that's good. Which one do you want to pick? Does it matter?
Not usually.
Not hugely. I think the first one's the laziest choice, right? So the first one, if we solve it for, we get z is equal to like minus x minus y, right? From 1. And then I know x is what? Minus 9/4. The 9/4, and then there's a minus here. And then minus a y gives me plus 1/2. Indeed. And a quarter is 2/4. So we've got minus 7/4 there for my z. So altogether, the point of intersection of the 3 given planes is actually 9/4 minus 1/2 minus 7/4. But that's, I'm just speaking geometrically. Another way of saying this, which is the way we'll talk about always pretty much, is that that is the solution to this system of equations, right? That's what you must make both x, y, and z all together the same in order to solve equation 1, equation 2, and equation 3 all at once. Now, I'm talking about planes. Let me just, again, I don't test on this geometry, just for your amusement. If you talk about a plane in 3 dimensions, like this, if this is your x direction, your y direction, your z direction, then you can describe a plane by an equation. So the plane has a vector which is normal to it. That normal we usually use ABC for. And an equation of the form ax plus by plus cz equals to d, this is the equation of that plane. So if you write ax plus by plus cz equals to d for any choice of a, b, c, and d, that gives you a plane in 3 dimensions. What happens when you take 3 planes in 3 dimensions and you look at their intersection? So my binder's like 2 planes, right? So they intersect along a what? A line, right? And if that line intersects with a 3rd plane, like this tabletop, then there's one point that's common to all 3 planes. That's what we're doing with the algebra. We're finding the place where these 3 planes intersect, if you want to think geometrically. Yeah?
Backing up a little bit.
Uh-oh.
How did you get 9/2 from the 4 and 1/2?
Fraction adding in the middle.
On right above x equals 9/4.
So 4 is 8/2, right?
Right.
So then I add 1/2 to both sides. You know, 4 plus 1/2 is 8/2 plus 1/2, which is 9/2. And then the finishing step here was to divide by 2. Good question. Other questions? All right, so what made this problem super friendly is that there was a way to take 2 of the equations and like add or subtract them in such a way that 2 variables vanished at once. Like there's a special, that makes this a very, very friendly question. There are slightly less friendly questions. Let's look at one of those. But not still the most unfriendly of all questions by any means, but a moderately less friendly question. Example 3. We could have something like x plus y minus z equals to something, and then x minus y plus 2z equals to something, and then, well, 2x plus 3y plus z equals to something. And I'll put down the somethings here in a second. Give me a second here. I got to think about my life. All right, I hope I thought correctly about my life. Well, if at any point we find a fraction as a solution, we know that I did something wrong just now in my head, which is possible. Hopefully not, though. Let's see. I try to make these things work out to like integers on your tests, just because it makes my grading easier, and it's all about me, right? So, no, sorry. I behave. That's not true. I really don't know how to behave. What do you guys think we should do? So you notice that there's no hope of like just adding or subtracting two of these equations and just poof, everything vanishing but one variable, right? So our goal is to eliminate a variable so we just have two variables. We know that if we can get to two equations and two unknowns, we got it, right? So how about we do, I think we could add 1 and 2, right? If we add those, what happens when we add these guys? Eliminate the y, so we get 2x plus z equals to 6. And we're going to give this a name, 4. All right, here's equation 4. What else can we do? We'd like to find another equation without y. How can we achieve that? Another equation without y. Okay, so yes, I like that. We're going to do 3 times equation 2, which gives me what? That gives me 3x minus 3y plus 6z equals to 5 times 3, which is 15. I'm going to stop right there. Does everyone understand what I just did? I took equation 2 and I multiplied it by 3. We multiplied the 3 across, right? So 3 times x minus 3 times minus y is minus 3y. 3 times 2 is 6z. 3 times 5, 15. Are we good? Now the reason that that was suggested by one of your peers is because he knew that that would make the 3y cancel. Right? So if we look at equation 3 here, equation 3 is what? 2x plus 3y plus z equals to 11. See, so the whole reason for multiplying that by equation 2 by 3 was to make these match up in the y. Now we add these, right? We add these, and what do we get? We get ourselves a 5x, and the y's be canceling, and 7z, and it looks like a 26. Now this is a new equation. We're going to give it a name. We're going to call it 5. I'm guessing most of you don't have children yet. When you have children, consider numbers. Right?
That's a good idea.
Have you ever met anybody and you're like, and they're like, this is number 1, this is number 2, this is number 3. It'd be really cool. No one's done it, right? This is something you're going to need to negotiate, like in maybe like the first couple weeks of dating.
I'm trying to name my child one.
You might need to like set your expectations lower, and just to make this go. But it's worth it, because then you'll have children named 1, 2, 3, 4, 5, 6. Right? That's here. Let's see here. No, maybe not. Okay. So equation 4 and 5, let's write them up. What do we got? We've got 2x plus z equals to 6, and we've got 5x plus 7z equals to 26. Now I think for these, substitution's a good idea, right? We can solve this by substitution. What should we do? Okay, yeah, this one here, right? That gives us z equals to what? 6 minus 2x, right? And then you can take that and plug it right in there, and that will give you an equation just involving x, which would be 5x plus 7 times 6 minus 2x equals to 26. If this works out to a fraction, I will be unhappy. So we have 5x plus 42, 42, minus 14x equals to 26, which gives me, it's not looking good, I don't know, minus 9x equals to, man, what's 26 minus 42? Negative what? Oh, son of a gun. Really? I'm not allowed to change them now, am I?
No.
Oh. Fine. Are you guys sure about this 16? Couldn't it be 18? I want it to be 18. Can't we just make it 18? I really want it to be 18. It would be ever so lovely if it was 18. What did I do wrong?
Were you just thinking multiples of 3 that happen to be 16 instead of
No, I was trying to make the solution 1, 2, 3. So like 1 plus 2 minus 3, 1 minus 2 plus 6, 2 plus 6 plus 3. So where did I make the mistake? Oh, it was 0. That one was right. That one was right. Hey, we can fix this. All right, follow me. It's worth it. It's worth it. It's worth it. This one, we're going to make a 0. Track it. I'm going to do the corrections in red. That makes this one a 0, which makes this 5, this 6 here, a 5. Doesn't matter. So 5. Five. I'm sorry, guys. This was kind of horrible. I have no regrets. Well, that's not true. It's not true. I regret that. All right. I think I've gotten all the offending. All right. What? No? The proof's in the pudding. This better work out to 1. What do we get here? Negative 9x equals 2. What is 26 minus 35? Negative 9. Yes. Now I feel much better. So, moral of the story, don't try to set up the equations in your head. You need to write it down and look at them. This is irrelevant to you because you're not setting up equations, you're just solving them, right?
This is a good test of how neat your work is, though, if you're able to go back and change all the numbers.
Well, thank you. And also, word to the wise, if you study my tests, you'll notice that often the answers are 1, 2, 3. Now, don't just assume that and write it down, because since we've had this conversation, the odds of the solutions being 1, 2, 3 are actually very low.
So are you saying?
Or are they? Or would I actually make it? Or would I actually make it 1, 2, 3 now, just to see if you derive it correctly, get to 1, 2, 3, and then doubt yourself and cross it out? Or would that be too cruel? Maybe I wouldn't make the. So if you've seen The Princess Bride, you understand what I'm doing.
Yeah.
Okay, so all right, very good. Inconceivable. All right, so z is equal to 5 minus 2 times 1, also known as 3. Woohoo! See how nice that is? Whole numbers. How do we get y? Yeah, which one should we use? Oh, the first one, very good choice. So number 1, I get x plus y minus z equals to 0, but I've got x is 1, and I've got z is 3. So that gives me y is equal to 3 minus 1, which is 2. So altogether, solution is 1, 2, 3. Yeah. All right, let me make up a problem where the solution is not 1, 2, 3. It's something hideous and horrible, and we need another method. How do you guys feel about these? Is there hope? I think you guys can solve these. Listen, is it hard to check your answer on these problems? It's really not, right? You need to, when you're done with this, it's very important on your test. Take your answer, take a minute, go back to the original equations, plug them in. Do they work? Right? Yeah.
I didn't have a question. I thought you were looking at me.
Oh, that's funny.
That's really That's so bad.
My eyes are kind of fuzzy, so my eyes are just fuzzy enough that I might have been looking at you when I was trying to look at her.
I was like stretching, and I was like,
You guys are so polite. It's adorable. Anyway, go on. Yes. Yes. In the back.
What is the best way that we can go about finding more problems like these that like take us through the steps? Because I mean, like, I get the concept.
Oh.
I just need it broken down just a little bit more.
Oh. Well, like you're asking for strategy.
Yes.
So here's the strategy. So, given, 3 equations in 3 unknowns. All right? That's step number 1. You're given 3 equations and 3 unknowns. The first thing you have to do is find a way, either by substitution or by adding or subtracting equations, to get rid of one of the variables. Okay, so step number 2, eliminate at least one variable, right? If it's like the first example I did, well, the second example for today, yay, we've already eliminated 2 variables. That was wonderful. But usually that doesn't happen, like my third example, right? If you eliminate one variable, this gives you what? 2 equations in 2 unknowns, right? And then what do? Then we're back to what we did earlier this week. Then we solve those 2 equations in 2 unknowns. 3, solve the 2 equation problem. And then step 4, plug back into one of the original equations. That's what we did. That's basically the method. And that's actually a wonderful question, because that's what I was about to talk about the rest of the class anyway, which is that the substitution method is just essentially what I wrote, except here's how it goes. You take the first equation, solve for a variable, all right? Then you take that and you plug it into the second equation. At that point, you have just 2 variables in that. And then you take that, solve for one of those variables, and then you plug that into the third equation. And you use that together with the first substitution you already had from the first step. And then that gives you 1 equation and 1 unknown in the bottom. But I find that this substitution method is like, I try to avoid it. I try to just add equations. But listen, you should just remember the goal is to eliminate a variable. As far as examples go, I think I have examples already written. Let's see if I can find them. All right, Top Hat, get out of my way. Should I bring in my son to do magic?
That'd be awesome.
I'm gonna try to get him to come and do magic for you guys. I told him he has to wear the suit. All right, so all right, so this is the college algebra website, right? And if you look in here, oh no. Oh man. I think I might have used matrices in these notes. Well, oh, here's one. Substitution. That's, well, this is your future, so you can ignore this for the moment. Let's see here. We've done this stuff. I want to see if I have any. So there are a couple more examples. If you look at the if you look at towards the end of this, like page 6 and 7 of my it's like number 22 under my old lecture notes. It's there. But I think if you look in the textbook, they've probably got examples too. But anyway, I know you guys got to go places, so see ya. Have a good weekend.
Thank you, Professor Cook.
Thank you. Turn this thing off before I